Hello class, so we're going to be talking about related rates here. Let us get started with a couple of questions. Length of each side of the cube is increasing. So keyword here will be increasing. The length is increasing here more than anything. And then at a certain point in time, the rate of the change of the volume. So here, the first one talks about dl dt, how the length changes over time. The second one here, volume, the rate of the change in volume talks about dv dt. Now, at the same is equal to the rate of the change of the total surface area, and this must be somehow equal to the surface area. What if I call it as S ds dt? Now, they want us to find out the length of this thing actually happening. So now, since we want to find out the volume and surface area, so volume will be equal to side length cube. Surface area would have been, we have 6 of these squares. So when you take the derivative, dv dt, we are assuming in this case that all variables are defined in terms of time. And we end up getting 3l squared and then dl dt. And in case of the surface area, ds dt must be equal to here then 12 L dl dt. But since they're equal to each other, just like it is written, we have to set them equal to each other, so we have 3 L squared dl dt is equal to 12 L dl dt. But as you can see, dl dt's are common, so we can cancel them apart. And we have 3, and then we end up getting 4. We have L here, and one of them cancels out, then we end up having L must be equal to 4. So the length of the edge will be equal to 4, choice number 4. Alright, let us move on to the second question here. The volume of the cone is decreasing at the rate. So here we are looking for, the first clue is dV dt. The volume is decreasing at the rate of -10 cubic centimeters per minute. What is the rate of the change in square centimeters? Now we're looking at ds dt when we are using each edge of the cube equal to 5 inches. So here we realize L is equal to 5. And once again, dV dt must be equal to 2 here, sorry. In order for us to get the dV dt, we are looking at V must be equal to L cubed. And then surface area, as we know, must be 6 L squared. Now when you take the derivative of each kind, we get to realize dV dt equal to 3L squared dL dt. And ds dt is equal to 12L dL dt. Now, since we know that the volume is decreasing at this rate, then we should be able to put these two values in. So we have -10 is equal to 3 times 5 squared is equal to dL dt. Once you figure this one out, you'll realize that we have -10 over 75 is equal to dL dt. Then, when you simplify this one further, we get to realize, dividing top and bottom by 5, we get -2 over 15. Now, in order for us to find rate of the change in square centimeters, surface area, that means ds dt must be equal to 12 times L, which is equal to 5. And dl dt is negative 2 over 15. And here we end up getting 5, and we end up getting 3. And 3 cancels out here, becomes 4. So our final answer becomes negative 8. Number 3. So here we have this length is always 3 feet above the ground. And of course the rope, why don't we call it as R, that changes, and X will be the horizontal distances, also changes. If the rope is pulled at 1 foot per second, that means we are looking at dr dt is equal to 1. How fast this canoe is approaching, so we are looking at for dx dt. So which relationship will satisfy x, r, and 3? All we have to do is first set up 9 plus x squared is equal to r squared, and then when we take the derivative, then this becomes 0. Here we have 2x dx dt, and here we have 2r dr dt. Alright, so 2 and 2 cancels out, and we need to figure out the value of x and value of r. Now, at this point, we realize that 14-foot rope's remaining, so then that means r is equal to 14. Then how can you find the value of x? X must be equal to square root of 14 squared minus 3 squared. Now 14 squared is 196 minus, so we end up getting x equals square root of 187. Then here I think we have almost everything ready, and x is equal to this value, so square root of 187 dx dt is our question mark. R will be equal to 14 times dr dt will be equal to 1. Then dx dt must be equal to 14 over square root of 187. So that becomes our answer. So let's continue with number 4 here together. So we have in the diagram 0 comma y, that means this length is equal to y. Here this length is equal to 4, and then theta. Now we could have used many things, but what dictates the relationship between angle and y value and then 4? We get to realize that there must be tangent theta. In this case, will be equal to y over 4. Because 4 is constant, so we can just write it as it is. But y, on the other hand, it changes, so we have to use the variable. Now, point P is increasing at the rate of 4 units per minute. That means here we realize dy dt is equal to 4. Now, then the question is, find the rate of the change of the angle. So the question is d theta dt. That is the question mark. When y equals 20. So then, what we have to do is first we have to take the derivative. And derivative of tangent becomes secant squared theta d theta dt is equal to dy dt times 1 over 4. Now, in order for us to find the secant theta, we have to realize the hypotenuse. Since x was equal to 20, y was equal to 20, this one is equal to 4, and then this one, if you're to use the Pythagorean Theorem, let's call this one as maybe d, you can set it up something like this. 4 squared plus 20 squared is equal to d squared. And obviously, d squared here becomes 416. So, in fact, secant squared and becomes 416 over 4, and then d theta dt is equal to 1/4 times 4, because dy dt will be equal to 4 from given, and we get to realize that d theta dt will be equal to 4 over 416, which is equal to 1 over 104. In this case, radian per minute. That's what we end up getting. Oops, my bad. This one would have been 16 right here. Hence, this becomes 16. Hence, this one becomes not 16 over 416. It will be 1 over 26. That's right. All right, let us move on to number 5. Surface area of the sphere is increasing. Surface area, then, of course, we are looking at 4 pi r square is increasing at the constant rate. That means ds dt must be equal to 16 square meters per each second. Now, the radius of the sphere increasing. That means we have to take the derivative of this. We end up getting ds dt, which is equal to 8 pi r dr dt. Now, so ds dt was equal to 16 is equal to 8 pi, and r, in this case, radius is equal to 3 meters. So we end up getting times 3 dr dt. Then what we end up getting is, when you divide by 24 pi, then we end up getting 2 over 3 pi is equal to dr dt. Over 3 pi. Choice B. Alright, let us move on to the next question, number 6. Now, area of the circle is increasing. Now, that means we are looking at area of the circle, which is pi r squared. It's increasing at that much. That means we are looking at dA dt, which means 2 pi r, and then dr dt. How fast, given this one, how fast is dr dt changing? But one thing which we have to realize, that area is equal to 16 pi, so therefore our radius must be equal to 4. Alright, now, we know the value of r, we know the value of dA dt, so we get to realize that increasing force of 4 equals 2 pi, and r equals also 4 dr dt, and 4 cancels out. Dr over dt will be equal to 1 over 2 pi. So therefore our answer will be choice A. Alright, we'll stop here for now. We'll continue with part 2 very soon. Have a nice day. Bye.